Hi, this is the review for test one. So I gave you practice questions for the first test, and so we'll go over them here. So these are practice questions for test number one. Practice questions for test number one. Okay, so number one. So you should refer to the sheet I gave you during this. Number one is to find a sample space S for the following experiment. Toss a coin 3 times and record the outcome for each toss. Okay, so you toss a coin 3 times. Let me use a new mark. So you toss a coin 3 times. So this is 3 coin tosses. So each toss is either heads or tails. Okay. Record the outcome for each toss. Because I want to define the sample space S. So the answer is to define the set S. So capital S is equal to, so you have either heads, heads, heads. Let me point out, right, the H is for heads, and capital T is for tails. Okay, so tell me the letter what the letters mean when you're doing this. Okay, so capital H is heads, capital T is tails. So you have H, H for heads in the first, second, third tosses. H, T. H, T, H. H, T, T. Those are the 4 where the heads is the first flip. Now these are the 4 where tails is the first flip. Tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. Those are the 8 simple outcomes for this experiment, and this is capital S. This is the sample space for that experiment. Okay, so that's number one. I'm writing that set. Okay, and tell me what the capital H is heads, capital T is tails. It's much easier than writing the word heads and tails over and over again, right? Just using H for heads and T for tails. Okay, because otherwise you have to write 24 words instead of 24 letters here, right? Okay, let's keep going. Okay, so number 2. Okay, so number 2 in the practice questions for test number 1. A card is drawn at random from a standard deck of 52 playing cards, so that each card has an equal probability of being drawn. Find the probability of drawing. So you need to know the standard deck of cards, right? The standard deck of cards consists of the cards Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Those are the 13 types of values of the card, right? Ace through 10 is 10, 11, 12, 13. So it's 13 values, and each of those values is 3 suits. So each of those 13 cards, so each of 13 card values has a heart, spade, diamond, and club, right? So each of those 13 types of cards has one of each suit, and so 13 times 4 is 52, so that's the 52 decks in the card. A heart is a red card, a spade is a black card, a diamond is a red card, and a club is a black card. So half the deck is red and half the deck is black, right? So for every type of card, let's say 7, you have a 7 of heart that's red, you have a 7 of spade that's black, you have a 7 of diamond that's red, and a 7 of club that's black. So that's all 52 cards in the deck, summarized this way. 13 values, each value has these 4 suits, and these are the colors of each of those 4 suits. Okay, so you need to know that. So part A of number 2 says, find the probability of drawing a card that is neither a club nor a 7. Okay, so for A, I'm going to make capital C be the event of drawing a club. And so for sure, I'm just going to write club in quotations. And then for 7, I'm going to put S, I guess. S is going to denote 7, drawing a 7, okay? There's 7, the word 7 starts with an S. So we want the probability that the card drawn is neither a 7 nor neither a club nor a 7. So I'm going to say not club and not a 7. Okay, so this is the probability that both it's not a club, so S prime, and not a 7, not S. So this is the probability of C prime, S prime. The probability the card you draw is not a club and it's not a 7. So the probability of C prime, S prime, what is that? It's just the number of cards that are not a club and not a 7 divided by the total number of cards in the deck. Okay? And so the total number of cards in the deck is easy, it's 52. So N is 52. But the number of cards that are not club and not a 7. Well, if it's not a club, right, that leaves you 3 suits: hearts, spades, or diamonds. So it's one of those 3 suits, heart, spade, or diamond, because it's not a club, and it's not a 7. Well, each of these 3 suits has all 13 values for that suit, right? There's 13 hearts, there's 13 spades, and there's 13 diamond. But it's also not a 7. So if you take all these 13 types and you think of the ones that are not a 7, there's 12 that are not a 7. So there are 12 hearts that are not 7, there are 12 spades that are not 7, there's 12 diamonds that are not 7. So in total there's 12 plus 12 plus 12. There's 36 cards that are not a club and not a 7. And so the probability of not a club and not a 7 is 36 that are not a club and not a 7 divided by the total 52 cards in the deck. So the probability is 36 over 52. Okay? And you can simplify that, but then that's the probability. Okay? So that's part A. So let's continue to part B. So for part B, you want to find the probability that's a jack, queen, or king. So J I'm going to put short for jack. Q I'm going to put short for queen. And K I'm going to put short for king. Drawing a jack, queen, or king respectively, J, Q, K, capital. So we want to find the probability of a jack, a queen, or a king. So we want the probability of a J or Q or K. So it's the probability of the event J union Q union K. Well, they're all mutually exclusive events, right? The probability, the event of drawing a jack, and the event of drawing a queen, and the event of drawing a king, they're all mutually exclusive events. And so the probability of their union is the sum of their respective probabilities. So the probability of drawing a jack union queen union king is the probability of drawing a jack plus the probability of drawing a queen plus the probability of drawing a king. And so so that would be the number of jacks, n sub j, over the total number of cards in the deck, plus n sub q, the total number of queens in the deck, divided by n, the total number of cards in the deck, plus n sub k, which is the number of kings in the deck, divided by n, the total number of cards in the deck. And so there's 4 jacks, 4 queens, 4 kings, and there's 52 cards in the deck. So this is 4 over 52 plus 4 over 52 plus 4 over 52. That's 12 over 52, and you can simplify that. But that's the probability. 12 over 52, and if you simplify it, you get 6 over 26, or you get 3 over 13. So in the simplest form as a fraction, you get 3 over 13. You could also write it as decimal. Okay, so the probability of a jack, or queen, or king is 12 over 52. Okay, that's part B. Now let's continue to part C. So part C, you want to find the probability of a black card. So I want to let capital B be the event drawing a black card from the deck. So capital B stands for black card. And so what we want to find is the probability of a black card. That's equal to the probability of B, event B. That's equal to the number, n sub B, the number of black cards in the deck, divided by n, the total number of cards in the deck. Well, there's 13 black and 13 club, There's 13 black spades and 13 black clubs, looking at the way I define it. There's 26 total black cards in the deck. Divided by 52, the total number of cards in the deck. You can simplify it, that's 1/2 or 0.5 as a decimal. The probability of the black card is 1/2 as a fraction in simplest form, or 0.5 as a decimal. Because that's part C, so that one's easy. And then for part D, we want to find the probability of a red jack. So I'm going to let capital R equal to the event of a red card. And I'm going to let J be the event of a jack. And so you would get the answer without all this work, but I like to use all the notation and the math we do because you can build on this and do more difficult problems with these ideas. Okay, so then we want to find the probability of a red jack. And so that's the probability of the intersection of the events. So it's not red or jack, it's a red jack, meaning probably a red jack is probably the card is both red and that it's a jack. So this is the probability of RJ, intersection of the event of red card and jack. So this is the number of red jacks divided by the total number of cards in the deck. And so how many red jacks are there? There's the jack of hearts and the jack of diamonds. That's 2. There's 2 red jacks divided by the total 52 cards in the deck. That's 1 over 26 in simplest form. Okay? And so the probability of a red jack is 2 over 52 or 1 over 26. And you can write that as a decimal also. Okay? So that's A through D of number 2. So that's number 2. All right. Okay, let's continue. So let's go number 3. Okay, so number 3, in selecting 10 cards at random from a deck of 52 cards, what is the probability of selecting 3 clubs, 2 hearts, 4 spades, and 1 diamond? Okay, so okay, so the probability, so we want 10 cards at random from the deck, right? So we want to choose 10 cards in total, out of 52 total cards, right? We want 3 clubs, 2 hearts, 4 spades, and 1 diamond. Okay? So what is the probability of that happening? 3 clubs, 2 hearts, 4 spades, and 1 diamond. Okay, so we want to find the probability. We want to find the probability of getting 3 clubs, 2 hearts, 4 spades, and 1 diamond when you select 10 cards at random from the deck. So the question is this a permutations or combinations question, right? So permutations. So when you have this kind of problem with permutations or combinations, first question you ask is this a permutation problem or combinations? Is this a permutation problem or a combination problem? And to answer that question, you ask the second question. First question, permutation or computation or combination. Second question, does order matter or does order not matter, right? Well, if we want to choose, we're finding the probability of selecting 3 clubs, 2 hearts, 4 spades, and 1 diamond, but does not specify the order, right? It doesn't say I have to choose the clubs first or the hearts first or the spades second or the diamonds third. Order doesn't matter at all. So order does not matter. I'm finding a probability where order does not matter. And so when order does not matter, it's combinations, right? Permutation would be if order matters. Combination would be if order does not matter. And so because order does not matter, this is a combination problem. And so we're going to find this probability using combinations, right? And when we find this probability using combinations, we're not going to ever use permutations. Once we decide on one, we stick to that the entire time. So the probability of 3 clubs, 2 hearts, 4 spades, and 1 diamond is equal to, the denominator is going to be how many ways I could choose 10 cards out of the total of 52 cards in the deck. So that's 52C5. 52C10. I'm used to dealing with poker hands. Okay, so 52C10, that's the number of ways of choosing 10 cards out of the 52 cards in the deck, where order doesn't matter. Now, how many ways can I choose 3 clubs, 2 hearts, 4 spades, and 1 diamond? Well, there's 13 clubs, right? There's 13 total clubs. There's 13 total clubs. There's 13 total hearts. There's 13 total spades. and there's 13 total diamonds. Try to put in the same order as I have that list there. Okay, so there's 13 of each. So if I want to choose 3 clubs, and there's 13 total clubs in the deck, I have to choose 3 out of the 13 clubs in the deck. So that's 13C3. That's the number of ways of choosing 3 things from a set of 13 things. Okay, so the first thing, so one thing I'm going to do is I'm going to choose 3. 13C3 is the number of ways to choose 3 clubs out of 13 clubs. 13C2 is choosing 2 hearts out of the 13 hearts. 13C4 is the number of ways of choosing 4 spades out of 13 spades. And 13C1 is the number of ways of choosing 1 diamond out of the total 13 diamonds. Okay, so 13C3 times 13C2 times 13C4 times 13C1, that's the number of ways of choosing 3 clubs, 2 hearts, 4 spades, and 1 diamond, divided by the total number of ways of choosing any 10 cards from the 52 card deck, which is 52C10. Okay, and so that's the probability using combinations because order does not matter. And so you calculate each of those combinations, and then you plug them in, you multiply and divide, and you get the final answer. Okay, and so to get that answer, I'm going to erase the top part here. Because I'm just going to quickly calculate these things. Well, okay, so the 52C10 actually would be a lot of work. So let me calculate some of them. 13C3 is 13 times 12 times 11 divided by 3 times 2 times 1. That's using the shortcut I told you. So 13 times 2 is 6, 12 divided by 6 is 2. So this is 13 times 11, which is 143 times 2, which is 286. Okay, so 13C3 is 286, because I reduced it to 13 times 11 times 2, so that's 143 times 2, which is 286. 13C3 is 286. 13C2 is going to be 13 times 12 over 2 times 1. 12 over 2 is 6. 13 times 6 is 78. And so 13C2 is 78. 13C4 is equal to 13 times 12 times 11 times 10 over 4 times 3 times 2 times 1. 4 times 3 is 12. 10 over 2 is 5. 13 times 11 is 143 times 5, which is 715. So 143 times 5 is 715. So this 140 times 5 is 700. 3 times 5 is 15. 715. That's 715. And then 13C1 is 13 over 1, which is 13. NC1 is always n. So any number C1 is that number itself. NC1 is n. So 13C1 is 13. Okay, so those are each of those 4, and you plug them in. And then 52C10, you plug in the calculator, and then you do the product of these 4 numbers, this times this times this times this, and the numerator divided by 52C10 in the calculator, and you get the answer. Okay, so that's number 3. Okay, keep going. Okay, number 4. Number 4 is count the distinct permutations of all letters in the word mathematics. Okay, so permutations means ordering. So if you have the word mathematics, good, I'm just trying to make sure I'm spelling it right. Good. So how many ways can you arrange the letters to have unique words in the unique orderings of the letters in the word mathematics? So how many words are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters in that word. So the number of permutations number of distinct permutations, different permutations of the letters in the word mathematics. I'm writing all this out. Okay, so the number of distinct permutations of letters in the word mathematics is equal to, well, there's 11 letters, 2, 4, 6, 8, 10, 11. There's 11 letters, so 11 factorial. There's 11 factorial ways to arrange 11 things, but then some of them are the same, right? There's 2 m's, so you divide by 2 factorial for the 2 m's. There's 2 a's, so you divide by 2 factorial again for the a's. There are 2 t's, so you divide by 2 factorial for the t's. There is 1 h, divide by 1 factorial. For the h, there is 1e, so you divide by 1 factorial for the e. There's 1i, you divide by 1 factorial for the i. 1c, you divide by 1 factorial for the c. And 1s, you divide by 1 factorial for the s. That's 2, 4, 6, 7, 8, 9, 10, 11. That's all 11 ones. So the number of distinct permutations of letters in mathematics is 11 factorial over 2 factorial times 2 factorial times 2 factorial times 1 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 factorial. That's equal to 11 factorial. 1 factorial is 1, right? So this is equal to 2 factorial is 2. So it's 2 times 2 times 2 times 1s. And so this is 8. So it's 11 factorial over 8. That's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 8. So the 8's cancel, and then you're left with 11 times 10 times 9 times 7 times 6 times 4 times 3. 11 times 10 times 9 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 1 times 2 is 2, times 6, 24, 120, 720. So the product of numbers from 1 to 6 is 720. 6, 24, 120, 720. 720 times 7 is 5,040, because 7 times 7 is 49, so it's 4,900 plus 140, so that's 5,040. So the product of numbers from 1 to 7 is 5,040. And then if you multiply 11 times 9, you get 99. You have an extra 10 here. So 99 times 5,040 would be, if you did 100 times 5,040 minus 5,040. So you would get 5040 with another 0. And then subtract 5,040, so you get 45,360. That would be subtracting 5,040. So then there's that, and then you just add another 0 when you multiply it by 10. And so the number you get is 453,600. So the number of distinct permutations of letters in the word mathematics is 453,600. So just check, that's 5,040 times 99, which is, oh wait, it's times 100. Let's buy a check. It's another 0 there. There's 2 zeros, I have to fix that. Okay, so so then it's 5,040 times 100 minus 5,040, so another 1,040. So that'd be another 1,040. So you get 489,960. That would be times 100 minus 5,040. Wait, that's 40. Sorry. It's 1,040. So then there would be a 9 there, and then, good. So that's 498,960 times 10. Sorry, now I got it right. Okay, it's 4,989,600. Okay, that's 11 factorial divided by 8. 4,998,600. So you get, check this one more time. 5,040 times 100 minus 5,040. So that's 1,040 less than that. I'm going to check this. 49. There's a 10 there. It's a 9, 10, 9, 10, 6, 9, 8, 9, 4. Times 10. So 4,900,000. Yep, that's it. Good. I just did regular subtraction. Okay, good. Better not to use it. On the test one, she is good. Okay, so that's 4,998,600. Okay, number 5. Number 6. Oh, sorry, number 5. Okay. In how many ways can there be a first place, second place, and third place winner in a race of 20 runners? Note that there are no ties. So this is order matters, right? First, second, third place. And so there's 20 runners. And so if 20 could win first, then 19, then 18, right? There's 20 first place winners. Then after somebody wins first place, there's 19 left to win second place. And then after somebody wins second place, there's an 18 people left to win third place. So 20 times 19 times 18 is the total number of ways you have first place, second place, and third place winner in a race of 20 runners. You just multiply these two out. So 19 times 18. So you have 342. And then times 10 times 2. So this is, well, 684 times, so you have 6,840. So 20 times 19 times 18 is 6,840. Actually, it's 360 minus 18, which is 342. And then times 2 is 684. Good. Okay, good. Okay, so that's 6,840. Okay, so 20 times 19 times 18 is 6,840, and that's number 5. Let's go to number 6. So a box contains 20 red, 15 white, and 5 blue balls. A ball is chosen at random from the box. If the ball is chosen is not white, what is the probability it's not red? Okay, so you have a box. Then you have 20 red, R is for red, 15 white, 15 W, W for white, and 5 blue, B for blue. So R is red, W is white, B is blue. So those are each of those events. Okay, and so now what is, if the ball shows it's not white, what is the probability it's not red? So we want to find the probability it's not red, given that it's not white. All right, so let me read what the problem says again. The problem says if the ball chosen is not white, what is the probability it's not red? So that's, we want to find the probability it's not red given that it's not white. In terms of our notation, it's the probability of R prime given W prime. Okay, probably it's not red given it's not white. It's the probability of R prime given W prime. So that's equal to the probability by definition of conditional probability. That's equal to the probability of R prime W prime over the probability of W prime. All right, well that's the number of not red and not white balls divided by the total number of balls over the number of not white balls divided by the total number of balls. Okay, so I'm going strictly by the definition here. So then the ends will cancel, right? And so you have the number of not red, not white divided by the number of not white. And so the number of not red and not white just be the 5 that are blue divided by the total that are not white. That's the 20 red and the 5 blue. That's 25. So you get 5 over 25, which is 1/5, and as a decimal, that's 0.2, because 1/5 is 2/10. That's 0.2 decimal. So the probability that it's not red given that it's not white is 0.2. That's number 6. Okay, so that's number 6. Let's go to number 7. Okay, good. Everything's working. Number 7. So for number 7, let A, B, and C be events with P of A is 0.6, P of B is 0.3, P of C is 0.2, P of AB is 0.2, P of BC is 0, P of AC is 0.1. Find the following probabilities. Okay, so for part A, P of A, B prime given C prime. That's the probability of A, B prime, C prime over the probability of C prime. Okay, so what helps me with these problems is to draw a Venn diagram. So let's draw the Venn diagram where you have set A, you have set B, and you have set C. So surprisingly, even though Venn diagram sounds very easy, if you don't do practice it, you get stumped on a Venn diagram question. Okay, so you have A, B, and C. The probability of A and B, the probability of B and C is 0. Okay, so there's nothing happening in B and C. I'll put a 0 there. The probability of A and B is 0.2. But since there's nothing in A, B, and C, then all of the 0.2 is here. The probability of A and C is 0.1. There's nothing here, so this is going to be a 0.1 there. All right, we got this from probability of B and C is 0. Okay, good. Probability of A is 0.6. There's already 0.3 here, so there's a 0.3 left there. The probability of B is 0.3, so there's a 0.2 there, so there's a 0.1 there. Probability of C is 0.4, and there's a 0.1 there, so there's a 0.3 here. And so this adds up to 0.3, 0.6, 0.9, 1. So this adds up to 1. Good. Okay. So the problem, right? Okay, so now the probability of AB prime given C prime is the probability of AB prime C prime over the probability of C prime. What is the probability of C prime? The probability of C prime, not being in C is not in circle C, so just add up the probabilities that are not in C. So 0.3 plus 0.2 plus 0.1, that's 0.6. The probability it's in A, not in B, and not in C. A, not in B, and not in C, that's only 0.3. So it's 0.3 over 0.6, and that's 1/2, or 0.5. So the answer to part A is 0.5. That's part A. Part B is find the probability of A given B. That's the probability of AB divided by the probability of B, by the definition of conditional probability. Probability of A and B is a total of 0.2, divided by the probability of B, which is 0.3. That's 2/3. As a decimal, that's 0.67 rounded to the nearest hundredth. Part C is the probability of C prime and B given C prime. That's equal to the probability of C prime B C prime over the probability of C prime. So C prime and itself is just C prime. So this is the probability of C prime B over the probability of C prime. That's equal to, if it's not in C and it's in B, that adds up to 0.3. That's 0.3 divided by the probability it's not in C, that's 0.6. 0.3 over 0.6 is 1/2 or 0.5. So C is 0.5. And then D, the last part, let's put D over here. Part D is the probability of B prime given A or C. Okay? So then this is the probability of B prime and A or C divided by the probability of A or C. Okay, well, what's the probability of not in B and in A or C? If it's not in B and it's in A or C, then it's up to 0.7. And then divided by A or C. The probability if it's in A or in C, that's 0.3, 0.4, 0.6, 0.9. So the probability it's in A or C is 0.9. So it's 0.7 over 0.9, that's 7/9. There's a decimal, that's 0.78 rounded to the nearest hundredth. Okay, and so that's A, B, C, and D of number 7. So those are all the questions in the practice questions for test number 1 sheet. Okay, so study this, study the homework, study the lessons, and good luck on the exam.